Okay, making some progress here. So I had the wrong pins of the 22V10. I have phase 0 and phase 1, which are the from pulse and the to pulse. And they both need to be low going. I had it somewhat strange. Anyway, the from has to go low, asserting the from device. And then in the middle of that, the to has to assert low to write it to the to device. So let's take a look here at the oscilloscope. Hoping you're close enough to see that. So this is that is the from pulse. And you can see where it's low going. That's where the from is asserted. And then the bottom trace will be the to pulse. If I can find it. Hello. Oh, come on. You can do it. There we go. I think you can see that. So the from pulse asserts itself, and then in the middle of the negative going from pulse is a negative going to pulse. So I have the from and the to now operating correctly. And so it is running. So if we take a look at, let's turn this light off. If we take a look at the accumulator, let's see here, we need to reset. There we go. So we can see down here, you can see that the address pulse is flashing. So it's putting things on the bus, and what it's doing is it's reading the I/O register, and it's placing that value in the accumulator. So it's copying this into both registers. So if I change the switches, you can see the accumulator change. So if I put in say 55, so now we have 5 here and 5 here. Then what's supposed to happen is the addition of 5 plus 5 should come out onto the bus, and that should get put onto the I/O device. So this should be the summation of 5 plus 5. And that's not working. So anyway, I'm getting closer. It is running a program. It is inputting and outputting. So it's reading from the switches, and it is outputting to the two registers, the A register and the B register. So that's working correctly. It is looping. So what it's doing right now is it's cycling 4 bits of microcode, so 16 microcodes, and repeating those 16 microcodes. We can slow that down if we want. On the, we can change the clock speed down here, and we can see that the bus gets asserted slower. But it should still operate. If I change a switch, it still operates. So it's not going too terribly slow. But we can see the bus being accessed. So everything is working correctly now, except for the last instruction, which is take the outputs of the ALU and put them into the output register. So either, well, I can see right away that we're not seeing any codes other than 5 and 0 on the bus. So I'm assuming the problem has to do with the ALU is not operating correctly. Either it's not performing its right instruction, which is, oh, of course, it's doing exactly what it's supposed to do. Ah, I get it. Before we controlled the S0, 1, and 2 lines independently, so I could set those to be an add instruction. But remember, what we've done is we've wired those into A7, A6, and A5, and so those set what the ALU does. And right now, this LED shows us which instruction we're operating at, and we're operating instruction 00. 00 has A7, A6, and A5 set to 00. So it's setting S0, S1, S2 to 00. 00 is the clear instruction, which says no matter what the ALU sees, put a 0 on the bus. And that's exactly what it's doing. So it's operating perfectly fine. The only way to make this do something different would be to change the instruction register to something other than 000. So it'll do an add instruction. But that means getting some value into here, and that's non-trivial. So I need to go the next step now. I think I need to actually start putting a program here in ROM and executing out of ROM and seeing if we can get it to do more. But I think right now everything is working perfectly fine. I'm a little confused about the there's a couple things going on in the microcode. There's a from pulse, a to pulse, but there's also the clock to increment the microcodes. And right now I have the clock tied to the to pulse just to make it operate, and I don't think that's absolutely correct. So I need to actually generate a timing diagram for the whole machine and make sure that our clock is really where it should be. There should be a clock, and then there should be a from pulse, a to pulse, and then another clock. So probably the beginning of the from pulse, let's see if I can do that. So the beginning of the from pulse is probably where we want the clock to be. So if I put this in here, it's still operating. So I just want to make sure I'm actually designing this thing correctly. Make sure the timing diagram looks like. We probably should document what the timing diagram should look like in this thing anyway. I'm a little worried about erased conditions when we start programming, so go from there. But anyway, progress. I think everything is self-contained, and it's actually back to where we had it previously, where it's actually running a microcode program. And it would be adding two numbers if S0, S1, and S2 were set correctly. I could pull those off and set them correctly, but I think it's better to keep going and see if we can't get a program running.